Great Falls National Park takes place along the Potomac River, which originates in the Appalachian Mountains and runs through Washington, D.C. Like the Appalachian Mountains, the Potomac River has existed for hundreds of millions of years. On one side of the river is Virginia, and on the other side is Maryland, so the park is in two states. This project is filmed on the Virginia side. As the name suggests, the centerpiece of Great Falls Park is a waterfall followed by Matter Gorge, a narrow cliff-lined area of the river. The falls and Matter Gorge were a crucial lifeline for the Algonquian native peoples and remain today as some of the most beautiful landscape features in the DC area. Here is a LiDAR map which shows the elevation changes and surface details of Great Falls Park. You can see the falls here, where there's a change from lighter to darker purple, which represents a drop in elevation. This drop in elevation indicates that the falls are a nick point on the Potomac River. The falls are actually a collection of cascades and rapids, with no individual waterfall in the collection dropping more than 20 feet. However, the river drops 76 feet in elevation over the mile following the falls. This makes the Matter Gorge area the steepest nick point east of the Mississippi. This nick point exists for two reasons: a drop in the ocean base level and a difference in riverbed rock erodibility. First, the ancient Iapetus River dropped in level following the last ice age. This forced the river to deepen its path, which leads us to our second reason. The upstream rock is high-grade metamorphic rocks such as gneiss, which formed 550 million years ago during the tectonic orogeny. These rocks are more difficult to erode than the downstream igneous rocks, which formed about 470 million years ago. This hard metamorphic rock also makes up much of the cliffs lining the gorge. However, the river was able to wind through these cliffs by following a fault line along which the rock was more easily breakable. This is why the Matter Gorge is such a straight and narrow part of the river. Today's Potomac River is very strong. It results in an average flow of 349,000 liters of water every second. Despite the steep walls of the gorge, about once every 2 years the water rises to the brim of the gorge and has even been known to overflow it. So how did this gorge, waterfall, and modern-day river come to be? Glaciers did not reach this far south during the Ice Age, but the temperatures of modern-day Virginia were still cold enough to create a lot of snow and ice. So much, in fact, that the ancient Potomac River's discharge increased enough to erode into the hard, metamorphic rock of its modern-day river basin. The torn up and fractured rock cliffs and massive boulders that have been carried into the middle of the river are evidence today of how powerful this river can be. Here's a second LiDAR map which shows the contours of the land. Here in red, you can see the outline of where the river basin was before the increased discharge of the Ice Age era. Then, after the river cut down, it created the modern, yellow outlined river basin. This is an example of river terracing. Today, there are now trails where the ancient river basin once laid. This area is 75 feet above the modern-day river. Smoothed over and potholed rocks provide evidence that this indeed once was the bottom of a raging river. And similarly carved rocks exist along the bottom of our modern-day river basin. And here we once again have the colored elevation LiDAR image. And on this image we can find further evidence for the ancient river basin here, where there's actually an island from this ancient river. And here we can see that island today, rising from what was once the ancient river basin and is now a trail system. According to the U.S. Geological Survey, the sandy soils on this island include samples dating from 10,000 to 5 million years ago and contain pieces of shells from pre-Ice Age floods. This river terracing process took millions of years to occur, and because the metamorphic rock here is so difficult to erode, the river changes very slowly over time. According to the National Park Service, the river geology looks exactly the same today as it did when this area of Virginia was colonized, and will likely look the same for hundreds, if not thousands, of years to come.